Hello everyone, so today we have a linear algebra problem. Find elementary matrices E1, E2, E3, E4 such that E4 times E3 times E2 times E1 times the matrix A is equal to R, where R is the row echelon form of this matrix A that you see there, which is, I'm going to read this across the rows, 0, 0, 0, 0, first row, 1, 2, 5, 9, second row, and third row is 4, 8, 1, 9. All right, so first of all, let's first recall what an elementary matrix EI is. So an elementary matrix EI is an n by n matrix that's a result of doing a row operation on the identity matrix. So if you recall, elementary row operations is one operation is swapping rows. This other second operation is multiplying a row by a non-zero constant and adding to another row, and third operation is to multiply a row by a non-zero constant. Okay, so those are our elementary row operations. And what this problem is getting at is you want to row reduce this matrix, and the way you do that is obviously by row operations, but you could also do this by mimicking the row operations and by matrix multiplication with these elementary matrices. That's what all of this is about at the end of the day. So how do I go about in getting this? Well, you're going to take your matrix and you're going to go ahead and try to get this into echelon form. So the first thing I see is I have a row of zeros on the top row. I don't want that. I'm going to go ahead and put my row of zeros on the bottom because that's what echelon form needs us to do. So we're going to swap the first row and the third row. And accordingly, I'm going to do this operation on the identity matrix. So if you took the identity matrix and you swapped the first and the third row, you would get 0, 0, 1, 0, 1, 0, 1, 0, 0. Okay. And right below this, I'm going to put the result of what I get. So down like this column, let's say, I'm going to put the result of what the operation up here was. So when I went ahead and swapped the two rows, I would get 4, 8, 1, 9, 1, 2, 5, 9. The second row stays untouched, and zeros all on the bottom. Now I'd like to have a 1 where the 4 is at, because that's like a pivot position. So I'm going to do that by swapping the first and the second row. And I'm going to write the elementary matrix that mimics that. So this would be 0, 1, 0, 1, 0, 0, 0, 0, 1. And we'll put that result right down here. So this would be 1, 2, 5, 9, 4, 8, 1, 9, and zeros. Next, right under that 1 where that 4 is at, I'm going to make that 0. So I'll multiply my first row by -4 and add the second row to make my new row 2. And doing that on the identity matrix, this would be 1, 0, 0, -4, 1, 0, 0, 0, 1. And I highly recommend, by the way, that you maybe stop the video for a second and go through these steps in finding the elementary matrices, as I think it's easier to understand if you try that out. All right, so for the next one, next step, where that 4, we had that, so that was going to be a 0. And sorry, I forgot to put the the results for each of this. Is a -19, and this would be a -27. All right, so I've got one more step to make this into echelon form. So when you have that -19, that's a pivot position, and I like to make that a 1, a leading 1, in other words. So I'm going to multiply the second row by -1/19. And I'm going to write out my matrix e to the 4th, which does that operation on the identity, and this is what you get. And that result will apply to the matrix right above, so it'll be 2, 0, 0, 5, 1, 9, 27 nineteenths, 0, 0. Okay. And that is it. This is in echelon form. I don't need to put this into reduced row echelon form. That's not what we're asked. You could do that, and you'll just, do, one more, it would be one more operation for a reduced row echelon form. So if you take the product of E4, E3, E2, E1, and you apply them on A, you get the matrix that you have right here. So it's all equal to this. So that is equal to R right there. Okay? That's the reduced, that's the row echelon form matrix. Okay, and basically, as I was saying in the beginning, you're mimicking each of the row operations, but instead of the row operations, you're multiplying by matrices. So E1 times A is what happens when you swap the first and the third row. The product of E2, E1, and A, that's swapping the first and the third row, and then the operation of swapping the first and the second row, and etc. That's how this would work out. Okay? All right, thank you for your time. Hope this helps.